AICTE 1 week short-term training program on research trends in renewable photovoltaic system and its research challenges phase 2. So by the way, before going to start the session, here are some instructions. Do follow them as usual. So all the participants are requested to mute your microphones and turn off your cameras. All the participants are requested to pin the resource person screen and suggested to listen the session and note down the key points, and also post your queries in chat box during the query session, and all the queries will be answered by the resource person. So it is a great pleasure to me to welcome such a noted personality who is none other than the man of greatness, Dr. Sudhir Kumar sir, head of the department. And now, it is also a great honor for me to welcome our resource person this morning, Dr. G. Venumadhav. Is presently working as professor, Department of Tripoli, Anurag University, Hyderabad. He was received his BTech degree in Electrical and Electronics Engineering from JNTU, Hyderabad, and did MTech degree in Power and Industrial Drives from JNTU, Anantapur. He obtained his PhD from JNTU, Hyderabad. Sir also completed MBA from Annamalai University. He has published several national and international journals and conferences. He also got an AICT RPS funding and JNTU Hyderabad Tech IP3 funding and one patent to his credit. He has written textbook on a modified DPC strategy for doubly fed induction generator, Lambert Academic Publishers. His area of interest is advanced control strategies of electric drives, renewable energy technologies, microprocessors and controllers, and network analysis. Sir have 10 plus memberships like IEEE, IETE, ISTE, and some other well-known professional society memberships. And now I request Dr. G. Venumadhav sir to take up the session. Welcome, sir.
Is it audible?
Yes, sir.
Okay.
Okay.
Thank you for the nice introduction and go on to presentation mode. Just kindly intimate whether it is you are able to see my presentation. So able to see my presentation, sir?
Sir, it is not visible, sir.
It's uploading. It is slow here. Net is slow.
Okay.
System is also slow actually.
Okay, so now it is okay, sir.
Okay. Sir, if there is any technical issue, please let me know. I have even connected with my mobile phone.
Okay, sir.
If there is any problem with the desktop, like I will go with my mobile phone. Morning, one and all. Today, my topic would be installation and commissioning. Is one, in two parts I have divided this presentation. One is installation and commissioning of research into that forecasting models, but still it is going, research is going on. So the data related to that particular the data related to that particular where do I get data so where do I get data I can get NASA from site particularly NASA site particularly, and other one is you can go with one more is KAGGL. Sorry, I'm drawing with my mouse actually. I don't have any other option. This KAGGLE, just go with this. You can get the data for solar and even wind, and analyze the things. The data is not available for the India. It is available for all European countries only. Okay. So site selection and acquisition. So that is what the data acquisition or data collection, acquisition of that site, particularly whether it is feasible or not, what we need to check. So once before going to machine selection or ordering, okay, this step, what we need to do is even we need to check whether it is feasible for micrositing. Okay, so micrositing is a first important step actually. What we do is with this wind technology. Okay. So micrositing is one important thing. So what we need to do, so we need to analyze the contour, land contour, the place or the location contour, particularly at that place. Okay, that location, and where we need to put on that wind turbine. So in particularly that is required. So what is this micrositing is? Sorry. Yeah, here is my pointer. Say the wind turbine I have put on somewhere. Say first wind turbine I have put on here. Okay. Say I'm not running to the exact mark. So the next wind turbine, say horizontally, I need to put down 5 times the diameter. Say this distance should be 5 times d. And if I put down the beside, say after that, or vertical, you can say, if you consider this to be horizontal, this to be vertical, then I need to place this wind turbine to be 7 times of d. So it may be applicable even for small wind turbines too, and even for what you say, this I am talking about large scale, okay, large scale power production. So why this is required? Please remember the amount of wind energy or wind being left on after capturing by this wind turbine and leaving this wind turbine should reach the other wind turbine 100%. Okay, it should not be say 50%, 70% or 90%. It should be 100%. It should reach this the other wind turbine particularly. And there should be gap between, otherwise there will be some shadowing effect, this kind of thing onto this wind turbine. So again, this is a research, and they have fixed on this particularly. So land contour is one thing what we do, and even how to place down the wind mills, okay, wind turbines in that windmill particularly. Okay, then we'll go with the machine selection and ordering. So here, please remember, old kind of technology was very, old, like induction generators only. Now the problem with different states is they are previously it was 7 to 8 rupees. Now they have reduced it down to 4 rupees, something like that. Okay, both even Telugu states and other states also. So 4 rupees 36 paisa something is there. Okay, so which is like making that people the amount of will not be retrieved back easily. Say 4.5 years, my rate of return will be there, but it may not be 4.5 years. It may be increased because of that. So the policies are also very important. So site preparation, particularly, so that's what related to micrositing. That is very important. Wind farm engineering, including micrositing. So that is the next step. So we have discussed discussed. Because the first thing is like the location may be good specific to our particular, how we are thinking of. It maybe say rocky kind of things. All things, these things will be need to be removed. Whether it is road connectivity is there, all these things we need to check and make it ready for the go with the micro siting kind of thing. Okay, so otherwise it is not possible. Then erection of the machines. So we are going with one side micrositing is done. We are going with the directly. We will not go with the grid interfacing. Particularly first, we will go with the free run kind of thing. Get the statutory clearances from the chief inspectorate electrical general. Then we go with the commissioning of the wind farm. Okay. So without the clearance of CEIG, it is not possible to generate even one single watt also. Okay, so they will check whether everything is good. Then only they will give that certificate that it is being you can start and it is being commissioned. Okay, then performance monitoring is a key aspect nowadays. We can either always need not climb to the top of the tower or the hub particularly. Okay, it is need not. We can get the data down the tower itself, or I can have remote monitoring where you can sit down in your control room and monitor the things. Okay, so that is what the performance monitoring. So here it would be nowadays, particularly for modern wind turbine, 100 to 500 parameters I need to monitor. Okay, so you may ask why so many, sir? So please remember, you can, if you add many things like many sensors would be put on your yard drive, okay, pitch system, then your torque, active power, reactive power, all VA, VB, VC, IA, VSC, etc. Like that, if you put on, add on all the things, it would be around 100 to 500 parameters depending on how much sophisticated the wind turbine is. Then training of the manpower. Okay, so here particularly Tamil Nadu people, they are pioneers into this, and even wind turbine manufacturing companies are from there only, and they are the people who are almost skilled people, particularly available for India. Okay, slowly the things are changing now. We have skilled council for green jobs. They are also training the people, and they can get from diploma to BTech level or even MTech. They can get the jobs now. Okay, fixing overall time frame. So the gestation period is very small compared to your thermal or any other conventional energy sources. This is best one to go with. Okay, I can once everything is good to go, I can make it for say 1 megawatt, or even if you take 1 megawatt particularly 1 megawatt, I can install within 1 month also if everything is good to go. So please remember that is the advantage. Okay, so this is how the moving on. So these are the opportunities particularly. So we have because you are research scholars also believe, and faculty also they can concentrate on these things. So challenging areas are, first one is energy forecasting. As I said, still this is very, very important because always it may not go with the models, whatever you are trying to predict with. Say recently we had that cyclone kind of things. Many times there was heavy rainfall. So like that we need to see that forecasting is exactly correct. Okay, that is very, very important. Great quality improvement. Still, of course, many papers have been come up, but modular level converters you can apply MMC to the present system and see the improvement. At laboratories or practically or simulation standard, then go for laboratory experimentation, then go for the practical. That would be good. New technologies even include small side wind turbines. Say example being given like this one. So I have taken this Stream Technologies, one of the company here in Hyderabad. It's a US based company. So they have come up with a solution. Always hybrid is good. Why means the reason. Solar will not be available 24/7. It would be available only when the sun rises and sun sets. Up till that only. After that, wind will be available mostly. So the best solution is this one. Okay. So we have something like the 7 years type turbines, vertical axis wind turbine, and they have even made a solar PV combination. Okay, PV module combination. So both is the best way to generate the power. Okay. So morning the both will be tapping the energy depending on, of course, wind may not be too much high, heavy. But at night, wind will be constantly good. So you can tap down the wind energy. Particularly, solar may not be available. Okay. Like an array. Okay. Completely that array being put on like this. So for island purpose, you think of this kind of technology. Sir, I am audible, like no internet connectivity issues now. Sir, is it good? Anybody over there?
Sir, everything is good, sir.
Good.
You are audible, sir. You are audible, sir. Thank you.
Yeah.
Sir, audible, sir.
I am on full screen, sir. Yes, sir.
Audible.
I'm on screen, but not I don't know. So that's the problem. So that's what I'm asking. Sorry for that. So this is how you can think of the technologies. This wind technology people they have provide solution for the island too, and even this kind of hybrid combination. Okay. So now what you can do is like. You can either purchase or put on a project, apply a project with this kind of technology with different types of MPPT kind of techniques, and go with simulation, particularly simulation part 2, and go with hardware, and you can apply do the project. Okay, either your research or MTech project, that kind of thing. So that is the best way you can go with. So new technologies like many HVDC side, particularly if you go for offshore wind turbines, you have still that MMC based, and even onshore particularly you can go with the MMC based particularly. Then one more concept is repowering. So just now I told, say these are the wind turbines, you are able to see this. Now say this is previously I put on say 1.2 megawatt at that time, one single wind turbine. Now even 2.2 megawatt is available. 2.6 is also available in India now. They are saying like 2.1, 2.2 now. So now I can replace that same the wind turbine. Okay, the technology being there, like with repower it with 2.2. Now, but only the thing is, if this windmill is already being connected to the grid, already as it is, it would be connected along with say hybrid or whatever the combination. But if I make it, repower it with 2.2, what would be the effect onto that? So what I need to do, if there is any fault like that, okay, I can analyze or I can put on a project over there. Like that, we can go with research. Okay, the challenging areas, as I said, like human resource development, the people still are not acquainted with this technology. Down south, particularly, they are much, in particularly Tamil Nadu gives more skilled persons related to this wind power compared to all other places. And of course, Tamil Nadu is leading, particularly in India. Okay, in wind power generation. Effective use of land. So like this, you can go with effective use of land. So the hilly areas are there. I can go with the wind, and wherever there is no for my constructing my house kind of thing. And of course, it is not possible in remote locations. All these are will be in remote locations only. I can go with solar too. So it will be a hybrid combination and effective use of land, particularly growing down small vegetables kind of thing in solar that I can do. Here also we can go with the vegetation, particularly because wind never ever nothing will happen. No shadowing effect kind of thing will be there. Okay, in particularly compared to solar. Okay, so I can go with vegetation and use my land effectively too. Okay, so the best one is hybrid combination, hybrid development with solar, biofuel, others. That would be the best thing. In particularly in the market, solar versus the wind is very famous. Okay, small turbines for off grid, say like this, what you are saying. So this is being constructed by Windstream Technologies for island particularly. Okay, so now they are these people have installed in Lakshadweep also. Okay, or nearest island from India. Okay, the island from very near to Chennai. Okay, so new technology and missions as I discussed. So that is what you can think of. In particularly coming down to lower end, the PMSM kind of technology or replacing the technology with new technology that you may can think of. And higher side, you may think of replacing the different technologies, the converter technologies, and different topologies you can put on. Okay, that you can think and go with the research. So this is what global total installed wind power capacity, wind power generation up till now. So here 650 or almost 651 gigawatt is the total wind power being installed all over the world. Okay, up till 2018 it was 590 gigawatt. Then almost 60 gigawatt being added in 2019. Total by 2019 it was 651 gigawatt. And with 236 gigawatt, China is the leading country. Okay. Here I want to say one single wind turbine. If you take onshore, what is the highest one single wind turbine capacity in the world now? Highest one, largest one. Anybody from the audience participants? One single wind turbine. So it is one single wind turbine is 4.8 megawatt. So from GE, General Electric people, for onshore applications for onshore, and off the shore, if you take one single wind turbine by Siemens Gamesa, previously it was Gamesa, it is Siemens Gamesa, it is 14 megawatt. Okay, so that means you can think of how much land is required if you convert into solar. Say this is only one single wind turbine. Okay, now I'm not telling like 10 single wind turbines. It is only one single wind turbine. So 4.8 megawatt means I require around 4 into 4, 16. If you just make it approximately 5. So 5 into 4, 20 acres land I require. Okay, to install particularly. So you can just convert it and think of how much land is required for solar too. Okay. So this is a big challenge particularly, and how much water is required to clean. So this is also a challenge. So please do think of that. And why this China is leading please remember they have this permanent magnet synchronous machines being developed at the largest scale. Why means that material molib I just forgot that name, just recently got into M. It starts with M, and magnetic material is with China particularly. And now EEC kind of companies, they have come up with the solutions from US and the European countries, and they are trying to make again PMSM more the number. Okay, but comparatively, if you put down the things like 60 to 70% in the world, 60 to 70% in the world are DFIG, double-fed induction generators, and 15 to 20% it is PMSM. Okay, and the rest of that it is induction generators now presently, but they are induction generators, they are obsolete, almost they are trying to replace with the new technologies. So if you just go on with so this is you can see the site for total wind power generation in India. I just clicked on time bit so let it is slow. So this is a site, you can show it to your students. It's a Wind Turbine Manufacturers Association. Okay, and he's the chairman. Okay, Sujlon is the leading, particularly, and Tulsi Tanti Garu is the chairman for that. And just see here, 38,263. It's up to October 2020, just before this month. This is the update, 38,263. Okay, so almost nowadays competition, but the target being given as per National Solar Mission is more for the solar. I don't know why, because of policies are these things like wind, they are neglecting it. But still, in future it may boost up because of offshore in future projects. So overall, 38 gigawatt. Particularly being generated by India, and Tamil Nadu is leading, I hope, 9,000 some megawatt. Okay, so they are the persons who are leading. So able to see my presentation, sir? Back? Right. Moving on. So this is a typical one example given from I've taken from Vestas company, B150 4.2 megawatt. So 150 is just see here rotor diameter. So here generally they will make the specifications to be like that. So V150 is the rotor dia, and 4.2 is the rating of the machine. So here it is the rate megawatt. So one single wind turbine with the rotor dia 150, it is generating maximum to the maximum. It is 4.2 megawatt. So we have something like cut-in wind speed, cut-out wind speed. This you can neglect it for the present sake. Again, otherwise you will be getting confused. So cut-in wind speed, cut-out wind speed, and the base wind speed. Three terms are there. Nowadays, for even the small wind turbines, they are trying to make it to the cut-in wind speed to minimum to be 2.5 meter per second. So here it is 3 meter per second. That means that's a minimum wind speed required to generate the power, to start generating the power. And cutout wind speed, say 22.5 meter per second. So great, we need to shut down the machine. It will be there is some limit crossing that they compulsory shut down. Okay, if it is slowly increasing the wind speed, like in the cycle, and the end of a machine, it would be 12 meter per second. Most of the cases, 12 meter per second. Where if constantly 12 meters per second wind speed is maintained, then we can generate 4.2 megawatt. Okay, and many other parameters are there. Okay, so here one important thing is full scale. So what do you mean by full scale is here, that means we are using permanent magnet synchronous machine. So okay, full scale converter. Okay, the meaning is full scale converter. That means the rating of this converter will be almost the rating of the machine. Okay, 4.2 megawatt. So all transport related clearances also being given. Okay, so hub height, it depends on what kind of structure you are going with, either lattice structure or tubular structure. Okay, so generally 110 meter or more than that. Okay, So these are the steps being involved in the installation. First important thing is foundation. The foundation stud type, foundation metal part type. Foundation stud type need to torque, give some torque to screw or unscrew that one. Generally, we need to tighten it, tighten the screws. Very heavy screws it would be. Bolts, nuts and bolts it would be. And whatever the structure you are seeing in that foundation, it is nothing but the control panel. So control panel, I can need not go on to the top of the tower. I can put down here itself and monitor the things and get down my data. And of course, remote monitoring will be also possible. So foundation metal part type, I can just put down that structure onto this and fix it directly. Okay. So permanent kind of structure being placed down onto that. But here one important thing is, if there is any small mistake being done during the foundation, again we need to reconstruct the foundation, which takes lot of time, and should not do that mistake. Okay, so never ever even 1 single difference should not happen. Okay, in that way we need to construct it properly. Then the tower. Okay, tower particularly it is not one single structure. It is of course two different types: lattice structure and tubular structure. Based on whether we part with to the panel room in go with the or the turbine. But whatever you are saying, the long on the top, it is nothing but nacelle, wherein we hit the gear box and the generator and all the drivetrain being placed inside this nacelle. Okay, so why the cover? To protect down from the environment, nothing else. Okay, so the generator is of two types, in particularly three types, but in famous in particularly is double fed induction generator and permanent magnet synchronous generator. So there is also is either if it is direct drive, it would be coupled down, or if it is the double fed induction generator, it would be coupled down along with the gearbox. Okay, along with the drivetrain, gearbox, and the generator. Then rotor, here particularly, the rotor is nothing but the wherein the to this hub, the rotor blades are being connected. Of course, in that is required. So generally, it would be 490 volts. So 60 volts particularly.
Hello, sir.
We have two different types.
Hello, sir.
Horizontal, sir.
Pardon, sir. Voice is cracking, sir. Now.
Okay. Is it good, sir?
Now it is okay, sir.
Okay. Maybe internet issue.
Okay. Okay.
Okay, sir. So we have two different types: horizontal axis and vertical axis wind turbine. So this it's a egg beater shape. So and in Canada it is very famous, and we have with National Institute of Wind Energy, they have installed one research kind of project And most famous is this one. In the many movies also you can see rural area, the country area, you can see Tirupati. You can see, you are very acquainted with it. And down Tamil Nadu particularly, and the coastal area near Kanyakumari. And in Telangana we have Parigi area. So that okay. So uh, 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 the change the pitch here for horizontal axis wind turbine. Okay, here the pitch cannot be regulated. Here pitch can be regulated. So that's best advantage for horizontal axis wind turbine. Okay, here the generator at the down the vertical axis wind turbine. Here the generator sits on the top of the wind turbine or the nacelle. Okay, here the generator is in the nacelle. So what is the disadvantage with that? The sudden gusts, okay, sudden change in the wind will be affecting the performance. Here nothing like gusts will be generally formed below the surface. It is not on the top of, because okay. So please remember that, like therefore that will not be affecting the performance. So that is the main key role. Okay, here no yaw kind of control. Here yaw kind of control is there. Where I can say once the wind direction is changed. Okay, so now this I can change it towards this side also. Okay, say I can move down my blades towards this side if the wind direction has been changed. Through wind vane I can get the parameter. So wind anemometer I can get the velocity, and I can change the pitch regulation also. So in that way I can control the parameters. Power regulation also can be done. So that is advantage. So that's what here being put down. So I think a few of them about this diagram. So generator is on the top here in the nacelle. Here the generator is at the bottom with gearbox. If the gearbox may be required, may not be required, depending on the permanent magnet synchronous generator. With the gearbox or without gearbox. A double feed induction generator if goes, gearbox is required. So this would be the rotor diameter. This would be the rotor diameter here, and pitch regulation can be done here, wherein pitch regulation cannot be done here. Yard is possible here. Yard is possible here. So that's the main key rule difference. Okay. So foundation, what we'll generally do first, based on your site preparation, site selection, then the data acquisition. The data is very important. Please do remember for wind. And once do micrositing with after the site preparation, micrositing, then we'll go with the foundation structure. Here, please remember, depending on the capacity, power rating particularly, they will make that length and breadth particularly, but depth particularly it would be 3 meters. They will dig down. Okay, 3 meters they will dig down generally. And if there is any problem with the land, we need to dig more in depth too, and make the concrete from the bottom itself. Make the concrete too tough to get it very solid. Okay, and we have two different types here. One is foundation stud type and foundation metal part type. Okay, so what are the here what you are seeing is refilling of the land. What they are doing here. Okay, refilling the land. Here, total concreting they have done, depending on if the land is not good. Okay, that kind of thing we need to take care of. Okay, so this is it would be looking like. So right from digging down, we will put down the concrete, like kind of what do you say, structure, mechanical structures. Then they will in reconcrete make the structures like this, and put down the main foundation being ready. Okay. And just see all the cables, whatever we are taking out, particularly to the control room or to the remote monitoring requirement, that just see it, it is there inside. Okay. I hope you are able to see. Then they are filling the concrete. Okay. Filling the concrete and it would be looking like this. Okay. So that the foundation, how it would be looking like. And we have something like foundation. This is foundation metal part. Seeing what you, and here it is foundation stud type. Like rods will be there and you have nut and bolt kind of thing. The heavy bolts will be there and you need to apply spark. Okay. Then coming down to the tower, we have something like this lattice structure. Again, it depends on the power rating. Say 750 kilo, less than that, it would be this lattice structure can be not too heavy. Tons thing will be sitting down over. So therefore, we can go with lattice. Problem with lattice structure is if there is sudden gust, sudden change in the wind, this may be broken. So that is a problem. Okay. And this is how what you're seeing is this is wind mast. Okay. If you see it, you have something like at different hub heights, the sensors. Okay. These sensors will be giving us the how much watt it can generated. Okay. How much flux density or power intensity. Okay. From the wind power it can be generated. So different hub heights they will put on the this what is a sensors, and around 263 active stations are there now. Okay, of course 690 some odd stations are there, but the problem is always people are not opting to this kind of technologies, and government also is not taking the policies too seriously. So this the stations are very less in number. Okay, all over India. So if you install this wind mast and get the data, that would be good for any kind of site. So this particularly, CVET people, they are doing a very good job in that particular area. Okay. So that's what. So this is lattice structure and this is tubular structure. Never ever this structure will be one single structure. So it would be divided into 3 parts. Or 2, we need to put on like the counterpoise kind of thing. Okay, if necessary. Right. Moving on. Nacelle. So this is how nacelle would be looking like after complete chamber being closed. It is you can see how much heavy it is. Okay, and please remember first point. You should understand first point. First point is your skilled people like these people. It is what you are saying with wearing the caps. Okay, the safety helmets. They are required. First one. Okay, particularly. Okay. So of course, wind data that is required. First case. Second case, transportation is required. 10 years back, look at that. Heavy vehicles. Nowadays, the logistics have been improved now. Transportation logistics, particularly now, there is improvement. That is important too. Okay. One example I can give. Please remember, along with logistics, transportation, one machine being ordered by NTPC people. Okay. And it was traveling from down south to Gujarat area. It took more than 45 days for statutory clearances. Somebody will stopping, they will be not allowing the vehicle to move. So in this way, again, I need to call this by that guy. This kind of problems had happened, and it took 45 days. So that is a problem. And third is particularly this. Heavy cranes are required lift up. Even years back, this kind of cranes were not available. Complete technology. Now they have got the technology too. Of course, 10 years back, if you take power generation, it's also very less also. Okay, at the time. So this is how the nacelle lifted up. Okay, from the factory, it will be taken, it would be get down and it would be lifted up from the side. Okay, just if you see the down, it is the yaw. Actually, it places with the yaw motors or yaw yaw control particularly. It either may be mechanical, but nowadays where the hub or the rotor blades are being connected. Okay, and torque properly. Okay, so inside this I can have all my sensors related things, and this axis connected to the hub or the rotor, and inside it would be the gearbox and all other drivetrain, okay, to increase and decrease the speeds. Okay, and at last it would be the generator, and on the top, generally on the top, it is all my accessories like wind anemometer, wind vane, all these things will come. Okay, so moving on, and now see the crane, heavy later. So that is carried down to uh, side with hub, uh, you know, displayed. Okay,
Sir, excuse me, sir. Hello, hello, Venu sir. Is my voice audible, sir?
sir, able to listen to me now? Yeah.
It's okay, sir.
Okay. I think again net connectivity was the issue.
Yes, sir. Network. Okay, sir. You can start, sir. No problem.
Yes. Yes, sir. So this is what control systems. All the parameters I can monitor it down the tower itself. Need not go to the top of the tower. If it is any emergency only, we can go onto the top of the tower through elevator. Previously it was ladder only. Now elevators are also there, and now sophisticated technologies have come up. Need not go to even top of the tower to fill the lubricant, etc. Okay, I can do it from the control panel room only. Okay. So commissioning, the chief inspectorate general, he has to give the permission. All the signals to all the different sensors, whether it is working or not, they will check. Okay, check the rotation of the rotor. Okay, particularly or motor or generator. Once it is done, particularly properly, it will they will go with the free running mode. Okay, running mode particularly they will go, and they will free wheel for 15 minutes or so. Once it is done, they will connect it down to the grid particularly, and the term therefore they will call it as commissioning. Okay, the term commissioning means putting down the wind turbine into operation. So the safety certificate is, as it is high, it's high tension kind of equipment. The safety certificate has to be issued by Chief Electrical Inspectorate of General. Okay, so without that it is not possible. So few things, a few basics again. Same as aeroplane, how it lifts up to the air. Okay, so whenever we take off and even during landing, particularly, this aerodynamics of the plane are very important. What do you say? Aerodynamic lines. Okay, what you are seeing here. Same thing applied to the wind also. Okay, so what will happen again? The basic principle are a high, what do you say? Capacity, low to low capacity kind of same thing, it would move down. So overall, we have three different types of forces being applied onto that. One is lift force, then the drag force, and the thrust. Okay, lift force is a key role player particularly, and the drive force will be the other one which would be aiding, and the thrust will be the opposition force. Okay, so all these are required. Without మనకు తెలుగులో సామెత ఉంది, like మంచి ఉంటే చెడు ఉంటుంది automatic, like that. So same thing, it would be applicable here. So overall, the closed triangle, okay, the right angle triangle, the closed hypothesis hypotenuse is nothing but the lift force. So lift will be the key role player over there. Okay, so it will make that so heavy rotor blade, not nowadays, not too much heavy, it would be lifted up easily. Okay, so this is one, a few parameters we'll see. This is particularly the rotor speed and hub longitudinal wind speed, how it would be looking like. If you just see, it is not constant. It is varying, completely varying depending on the time. Okay, so it is for 1.5 megawatt wind turbine operating at 14 meter per second and full RPM. So it is varying, sometimes it is more than 14, then it is coming down, so and so forth. Okay, it is moving on. So it is not constant anytime. This is how the pitching of the three blades. So three blades, it is particularly for symmetricity and one thing, and never ever a breakage or physical damage will happen, because equally their forces will be distributed. So compared to single or two rotor blades or any other things. Okay, otherwise previously it was complete, it would be used for applications like water lifting or agriculture kind of purpose. So but now the best way is the three rotor blades, and if you see the pitch of that particular three rotor blades with respect to the degrees and time, it is varying. Okay, so how it will vary, it depends on the wind velocity, wind speed particularly at that instant, how it is changing. So accordingly, it would be changing to make the see that the we'll get the base wind speed 12 meter per second, particularly for the gear, and of course from the gear the that speed will be increased. It will be made to 1500 rpm constant or less than, so whatever the rating, okay, greater than that, and we can go for the generator mode. Okay, so basically that is the main key thing which will happen over there. So this is how it would be, the pitching of the blade will be looking like. So this is always, as electrical people will know, so overall shaft power available, it would be more, and compared to the electrical power, because there is some losses overall with the once you come down to electrical machines, we have wrote the shaft power which is available. So in megawatt scale with respect to hub wind speed. So overall, this is how from the wind power to the rotor, it is connected to the converted, that power being converted or energy being converted through the gearbox, and it is tapped down from the to the generator, or the main power is being tapped down. Then we have something like power converter, power transformer, and supply to the grid. So that's what I was mentioning. This diagram shows that this will be 5 times of D. This would be 7 times of the D. Okay. Once the wind, whatever it is left from this two wind turbines, it should reach the other wind turbine. Besides, it should reach 100%. Okay. And if you go with the CP power coefficient of 1.5 megawatt wind turbine, it is looking like this. Okay, based on hub wind speed and the power coefficient. So generally, maximum, if you take the maximum value, it would be 59.3 as per Bed's limit. So thrust force, this is how it would be looking like. It is the opposition force. And of course, one point I did not mention here. So I can sorry, here I will go. So I can make the pitch in such a way that it will be opposing the thrust. Okay. And if I require braking of the system aerodynamically, I can do by using the pitch too. That is the advantage with the pitch control, which is not possible with the this vertical axis wind turbine. Okay. So I can go with the braking of the system in 3 different ways. One is aerodynamical braking. Second one is the mechanical braking, of which I have normal our clutch kind of braking, or the normal gear kind of brake being applied. Clutch is the disc braking. Disc braking is the latest one. Okay. Otherwise, normal braking, and this one will be the aerodynamic braking, where I can regulate the complete pitch in such a way that it will oppose the thrust and it will stop down rotation whenever it is required, because the winds will be too high sometimes. Okay, so that is what thrust force. And if you see the construction of a blade, it is nothing but, again, it is derived from the nature only. Again, you can just type whatever I put down in the starting, Vedas. So you can think of it is again same, the feather of a bird, and inside how the bones are there. In that way they have arranged this. And the gel coat they have put down like color in particularly, because never ever anything should stay on that, it should fall away. Okay, never, because it is also make some difference. Okay, and there is one more technology being embedded nowadays. It is humpback whale. Okay, so if you just look the closer look of that, and without any gel coat kind of thing, it would be like humpback whale fins. So the study from the nature says that the humpback whale will come down from down to the top very quickly. So because of these fins, so the same kind of technology will has been embedded into this particularly. What is why they have done this? Please remember, the first problem with the wind rotor blades is the noise. The noise we need to reduce. There were many complaints from the European farmers, or wherever we have put on the tree in remote location, there were heavy noise in the night, during the nights. So they have complained against that. So many of them, they have left their own houses, and they left because of this wind mills particularly. Okay, and the second one is the rotor blades will be crushing down bats, birds, etc. So this is the big problem. Many complaints again, from the environmental people. This was a problem. So nowadays they have, putting down some kind of red light kind of thing. Okay, LEDs kind of thing, wherein the bats or birds should not reach down or come down towards that rotor blades or the wind turbine. And for noise, this kind of technology is being embedded into that, so that it will reduce down the noise. Okay, so that is what therefore they have put on the technology in this way. And of course it would be aiding for all other things too. Okay, stalling effect, etc. So these are the different configurations we have. uh, we have hub. Okay, we have this shaft being there. Okay, and green is the gearbox and generator. Some, please remember, here we may don't have any kind of gearbox. That is generally permanent magnet synchronous machine. Nowadays, which China, if you take W-fed induction generators, they did not go at all. Very few. They have gone with permanent magnet synchronous generator like this. Okay, and normal W-fed induction generators like this, particularly with the gearbox, it would be coming down. Okay, and of course sometimes we can even avoid the shaft too. Okay, so this is also possible. Okay, but very rare case seen this kind of thing. And of course the nacelle, inside nacelle it would be there. So these are the different combinations. So drive components, if you say inside, this is how it would be looking like, and all the drive trains will be looking like this. Okay, some bearings and the total gearbox particularly, and this is what a permanent synchronous machine would be looking like. Okay, so that's what's drive. Direct drive is nothing but permanent magnet synchronous generator only. So the construction, it is very different. Okay, compared to all other induction generator or the W-fed induction generator. So wherein the stampings will be more in number. So that is the main role over there. So you have just yaw drive. If you just see this, these are the yaw motors or yaw pneumatic systems. Okay, and this is, if you just see the the disc brake particularly, and you have something like park braking too, where I can go with that park braking. This would be rotating smoothly, and this will not be carried down that power. Can go and if there is any maintenance that I can come down. This is all possible. Okay, so this is the important slide. Like if you come down with the components, we just see the generator. It is in terms of components, it what do you say, contributes around 3.44% only. But please remember, this is very, very important, including the gearbox. But the costlier equipment is the generator. So the costlier equipment is sitting down on the top of the nacelle compared to the vertical axis wind turbine. Maybe it may be in terms of components, it's very less, 3.44% only, but it is very costly compared to all other systems being present. Okay. So we have something like active and passive torques. Okay. Because of that active and passive torques, active torque, nothing but the gravitational pull. Okay. And other passive torques like friction, all other reactions. Because of that, you can see the axles, how it was destroyed. Okay. Completely run off. Okay. So particularly that it would be taken place if you are not maintaining properly. Okay. And so many forces are being applied, particularly if you just check with these equations. Okay, and different types of forces being put down on the main bearing particularly, and if maintenance is not proper, this may happen. Okay, so therefore maintenance is also very important. Main gear, this will increase or decrease the speed. Generally the input speed, say it is 12 rpm. Okay, the rotor is rotating at 12 rpm. So the 12 rpm to 15 rpm it would be maximum. So maximum it would be 15 rpm. That would be converted into say 1460, whatever it is. Okay, the rated rating of the speed. Okay, so that would be, it would be rotating at that rpm. So who will do this? Main gear will be or gearbox will be doing that one. So you have something like mechanical people will be knowing better. So we have planetary gears, and we have something like helical gears. So this is how it would be looking like, particularly the gear total drivetrain. This is for 750 kilowatt gearbox and the main shaft. So one main stage, and you have two planetary stages, okay, parallel stages. One planetary stage and two parallel stages. That means the power transmission or energy transmission can be done with that particular, say, connection, okay, either increase or decrease. So depending on my necessity. So here it is for 2.5 megawatt gearbox, two planetary stages and one parallel stage, okay. So it is very compact, particularly. You have something like couplings. Our electrical machines lab, you are very generally you will see this very familiar. Particularly, you have something like the flange type. Okay, this rigid couplings will be there. Okay, or flexible couplings like this kind of thing. So wherein I need to connect down that. This is also very key role player, because if that is not working and something happens, never ever our generator will rotate. So through the gearbox, the generator rotates with this coupling only. Okay. So therefore, this is also important. Okay. Next is shrink fit coupling. This is again a bit important in sometimes, wherein if there is any defect, particularly, what they will do is they will make that pass through the this nitrogen, liquid nitrogen, and make it thin film kind of thing will be formed, and it would be completely fit down. Therefore, the name shrink fit. Okay, so it fit downs that particular this end, gearbox end, and the generator end. So this is one of the other coupling where we can use, and this is bit famous, particularly being used. And this is fluid coupling that nowadays we I hope in the laboratories, particularly electrical laboratories, we are using this fluid coupling. And brake, as I said, we have aerodynamic braking. This is nothing but because of pitch system, okay, pitch particularly, and other are nothing but the mechanical braking, which is divided into disc brake and clutch brake. Okay, so disc brake is now famous. All motorcycles or mopeds, they are giving particularly with disc brake, and of course the clutch brake is old kind of system. Okay. So both are, you can go with either. Now presently they are going with disc braking, and of course along with aerodynamical braking we have. This is what park braking. Okay, we can just put on the park brake, or go with the park, and see that this will be free wheeled, and this will not be rotating. And here, if there is any maintenance, you can do and come back. Okay, you have aerodynamic. How the parameters will be looking like. Why it is falling means we are just stopping down it is being stopped down, so therefore it's slowly being fall down. Okay, aerodynamic torque is that black brown in color. Low speed shaft torque is the red in color. Okay, so slowly it is coming down, and slowly it is, because any fan or anything, it will not suddenly stop because of that moment of inertia, and the mass of that particularly, it will be slowly stopping. If it is very heavy, it will stop suddenly. So electrical power, that is green one. Okay, and that brake torque, okay, is a blue one. So we are not applying anything. Okay, so this is how the parameters will be looking like. And one important thing, if you just this is the thermal vision. So in particularly, if you just see the tower, down tower, the opening of the tower will be like this kind of shape, wherein I can go climb that staircase here and go to the top of the tower particularly. Okay, this opening, why that kind of shape only is, please remember, if you put down a shape like a rectangle or a square kind of thing, this kind of shape, okay, the stress being put down onto this edge points will be too high, and the slowly cracks, micro cracks slowly, the once the aging goes, okay, age of the tower will be going high, it will collapse, particularly the tower totally will be collapsing. So therefore the opening will be shape of oval particularly, oval shape they have put down. Okay, so electrical side, this already, we have something like generator, main contractors, main contactors, then transformer, then switch gear, then the grid. Okay. So if there is anything happen, this will switch gear will be taking care. Of course, the switch gear will be there, or the cut off kind of thing can happen towards this side also, because we have something like that kind of technology being embedded nowadays. Okay. And the generator will generally maximum value up till now available is 690 volts. Okay. So that is what I was mentioning. This is how the old kind of machine it was, induction machine. We'll see, and this is how the W-fed induction Skribis drive or Kramer drive. Okay, it is nothing but Skribis drive actually. Okay, so that being extended. Okay, this topology being taken from that topology only, or recovery scheme only. Okay, so we'll come back later. This again it is being covered. So capacitor bank, why it is required for generally we require if there is any fault during particularly to give the reactive power, one thing, or particularly to compensate particularly the reactive power there. Okay, or for starting purpose particularly. Okay, so here in this is very very important. But if you take the old kind of systems nowadays, this they are not putting down old kind of technology. If you just so they are taking down the power now through the grid, and these sensors are required continuously the power. So therefore we are taking down in this way. So this is before start. During operation, the normal operation, it would be V cut in, less than V wind, less than V cut out, and grid is available. Now the wind turbine is generating. So through the generator, it is coming down to the rectifier unit. Through the line converter, it is given to the grid. Okay, and the same way, I'm taking down the power being generated from the generator, that is taken to the rectifier unit, through the rectifier unit to the supply unit to all the sensors. Okay, which are load here for me too. Okay, of course, grid is the other load, and this is other load. Okay, or continuously the power is required for that. Okay, now when the grid is out, again the supply is required for the sensors. So this is not there completely. This section is not working. Grid is not available. So generator is generating, then rectifying unit. Okay, rectifier unit to supply unit, then all the sensors. So these are the three different modes of operation. If you just okay, the opening. So overall, we need to monitor 100 and 500 parameters totally. So these are the different examples of parameters being considered. Here only few being given. So wind, pitch, temperature, power, rotary, frequency, etc., etc. But for modern wind turbine, it is 100 and 500 parameters we need to monitor. So think of how much data you daily it may be required, to store it. Okay, so it may be cloud or anything, but we need to store it for statistics. Okay. So this is what I was saying, like US charges, okay, unscheduled interchange charges will be very high if you are not generating the power as per whatever you are, you have put down for the Genco, particularly that this much amount of generation I will do. So if you are not doing like that, then UI charges will be more. So that is what we need to perform in such a way that it has been following what we have stated, what we have predicted, what we have forecasted, what we have given the data to the Genco. Okay. So we have something like protection of all related protections, required protections, right from top nacelle to the bottom of the tower. The required sensors are being put down for protection, particularly even or trip circuitry, monitor relay, everything, emergency stop for the nacelle. So all these things are being placed along with this generator. Okay, wind turbine. Speed measurement, Hall sensor, and that is required compulsory for the control purpose. Okay. So we'll be placing at the good winds. So these are the yaw motors. So 4 yaw motors, so 4 yaw pneumatic kind of system. But nowadays they are using motors only. So they will be placing in the good winds. based on the input from the wind vane. Okay, and we have lightning protection. We here the standard being followed is IEC 61400. We have something like the zones of protection, and there are if the rotor blade is say rotated as a rotor blade is at this position, and say the lightning has been struck down at this instant. Okay, so please remember it will be the lightning structure will be a line, small line being put on, and all the three will be connected down to the grid. You have something like lightning arrestor on the top of the nacelle, along with the all other required station, weather monitoring stations, along with wind vane, wind anemometer. Okay, so we have something like this zones of protection: zone A, zone B, zone C. So that's what being explained. Okay, and if there is any lightning too, nothing will happen. So remote access nowadays we can control the whole wind farm through remotely. Okay, so that is also possible, right? So this is how overall it would be looking like. Small view of the wind turbine, one single wind turbine along with the grid connectivity. So this is one of the research being done by Germany. It is vertical axis wind turbine. So they are trying to do this kind of wind turbine. Next topic will be going with grid integration. A lot of time for the previous slides. Okay, previous installation and commissioning, but that is required. Otherwise, we will not understand anything. Okay, so grid integration of wind turbines. So we have something like many integration issues that is not so easy, and Tamil Nadu is now facing a lot of problem because they are leading pioneer in this wind power integration, and suddenly nowadays what I'm hearing is like the wind turbines are suddenly stopping. The power failure is happening most of the times. So the problem is actually what I heard is like if you take USA, particularly any kind of solar or wind, if they go, they will put on a separate STATCOM with the design specification. They will put on the STATCOM for that particular renewable energy source being generated. Here, never ever will put on that STATCOM kind of thing. So that is a big problem. Compensator is required particularly to withstand if there is any sudden change particularly. So either we need to make the fault to get rid of as early as possible, or otherwise somehow we need to see that it has been compensated by the grid somewhere. Okay, so in that way this is a big challenge. Nowadays they are trying to put on compensators into the grid, but very few they have put on. So that is the main reason. So the main big challenge is first and foremost thing, the design and operation of the power system. Okay, whether really the power system, electric power system which is already there, it would be withstanding whatever we are telling, feeding it to the grid. So that is very, very important. Okay. Then next, grid infrastructure issues. So I am generating the power either from solar or wind, but to evacuate the power, whether the transmission lines itself are available or not, that's a big challenge. Okay. So here near Dacharam, we had visited that solar plant, 4.5 megawatt. They have company people, particularly they have installed 4.5 megawatt, but the substation was very far away, around 9 kilometers. So then they got tie up with the government, TSS, PDCL, and they themselves. So 4.5 kilometers they have constructed the transmission line, to evacuate the power, and the other 5.5 line from the government. So in that way they have tied up. So these are the big challenge. Our infrastructure issues is also problem. Nowadays, other kind of thing like logistics are now not a problem, but still there are few hiccups. Then grid codes. Now the grid codes are really important. We need to follow. Now the grid code says that never ever any kind of wind turbine should be stopped. Previously it was stopped, and again to reconnect, synchronize it back to the system grid, it was taking 20 to 30 minutes. Again, it's loss of power So nowadays, at that if any fault kind of instant, the wind turbine should freewheel itself, and of course the power may not be generated but not be given to the grid, but it should freewheel itself at that instant. And once the thing is restored, say the fault is restored, it has to connect back to the grid immediately. So no time lagging kind of thing. But nowadays the technology is fault right through technology is there along with the system. Maybe the cost of the wind turbine will be increased. Say sir, able to see my screen?
Yes, sir.
Okay. Sorry, power failure again. I'm connected with my mobile. Sir, how much time I have? Can I go with more 15 minutes?
15 minutes more, sir.
Okay. So I'll quickly go through the slides, sir. Already we have covered most of the points. So, great, sir. Grid code says like wind turbine should not be stopped, sir. It should be generating the power continuously, and it should be connected. May not sometimes may not generate, but it should connect it continuously to the grid. Okay, so that is the grid code says. And market shoes, I will give one example. I don't want to name the place because it's from Andhra Pradesh only. Okay. Of course, here also there are, in India, it is not problems are there. Some, market disputes like comes like this too. The person is from, the ruling party, present ruling party, and other one was the previous ruling party. Okay, so he had not won the that elections at the time. So what had happened is like the person who is ruling party, he said like for this 90 megawatt windmill, whatever that maintenance people are required, you need to take from my party, my people only. The other person came to know about this and he said like no. Every people they need to be from my people only. You should not take from the other person. So this is what happened actually, and this led to the quarrel, and they have trashed the people from the train the mill actually they were working. They trashed like blue, black and blue. So because of that, they have closed down total wind mill, and they have moved back to their own place. So 2015 June or July, it has to be commissioned at 90 megawatt. It has been commissioned in October 2016. Okay. Again, involvement from the central people, even Minister of New and Renewable Energy, they came to the elect and they have done the, this, what is it, the things solved. And this, cleared. So these kind of issues will also come. So that is also important. Market issues is also problem. So here nowadays we have we'll come back these two slides later. So these are the terminologies which is very important. If you just see the x-axis from milliseconds to seconds, seconds to minutes, minutes to hours, hours to say 24 hours, like the year, so on and so forth. If you see milliseconds to seconds, what is the important parameter for us? It is power quality. Okay. So all this flicker, this voltage well, okay, all etc. etc. Voltage. Okay. So this is the major issue we need to consider. Now the technology is available to make it compensate this one. So you have something like all the other parameters like this we need to see these parameters already I think you companies for power systems you will be able to know more particularly so all these parameters we need to take care of okay so nowadays if you take the forecasting they are taking for 58 okay 58 they need to tell that to 58 how much amount of wind power you will use. So minute to minute, hour to hour, hour to 24 hours is also important. Okay. I can go with either load forecasting or the system results or past variations present in that particular wind farm. So this is we need to consider particularly for our cities to know the effect on the wind or wind farms. Okay. So long-term variations also like as a system planning, it is overall it goes with the system planning, long-term system planning that is very important. And of course, the power trading that is also required particularly. Otherwise, it's not for a small company. Now, if you are generating if you are on the top of your house and connect it down to night meter and if you're not able to bring it down properly, how much is being generated, how much it can generate, this is very important. It's a lot of people see this completely. Okay. So why this interconnection is required? It is required. Why? We need to, ideally start somewhere. That is very important. Any project or anything, we need to start it somewhere. Okay, so that the forecasting errors should be reduced, aggregation of wind power is done. Okay, how much we are able to generate. The accuracy, particularly we will be able to increase even in the prediction of the forecast. That is very, very important. Otherwise, we are not doing this thing. Somebody are not starting, it will be work on something also. So these are the three important things. The impact overall nowadays is just the penetration was very, in terms of percentage. Particularly, if you take, I think more than 20% also for Tamil Nadu, now they are facing the problem. Okay, the penetration of the wind power into the grid. So they could have think of particularly what could be the faulty conditions at the time what we need to do. So that is important. Grid size is also important. Okay. So in particular in that case, whether I can able to really generate that much amount of power connected to the grid. Whether it really uh, this is generation which from different topology say solar wind, particularly if you take I mean with different applied to and connect down to the grid. So generation will also vary. So with the generation mix particularly that how the power system will be affected. That is also important. We need to have all this clear picture. So local area impacts will not be, visible. It would be within specific to the windmill or wind farm. And system-wide impact will be nothing but overall total system being affected. So this is very important. We need to take part of local area impacts also, so that it will not affect the system-wide impact. Okay, it will not lead to the system-wide impact. So that is also important during this total consideration of the installation between the wind farm. So this we have covered. So this is example. It's an old slide. If you take Norway's leader, so how much wind penetration being done during very 2004 at that time only. So the European countries now they are slowly moving down totally towards renewable energy compared to all other countries, Germany, etc. This Finland, these countries they are trying to go with total renewable energy, particularly, and they are closing down every conventional energy source generation source, particularly. So at that time only the penetration was increased compared to at that time particularly increase in the wind penetration. All this varied. Okay, so that's what this slide gives us with the capacitor side, wherein how I can reduce down and go towards the unity power factor. Okay, the thing how I can compensate the reactive power and go to see that the system will go towards the unity power factor. Okay. Next, this is limited variable speed induction wind turbine. So again, rotor induction generator. So here, if you just see, it is variable resistance being added. So again, induction machine control of which slip ring induction motor she had taken. Okay. So again, it's a limited variable speed only. Okay. So now this is the case where the world is going with designed permanent magnet synchronous machine. So this is type C category. So you have AC DC AC converter here. The small wrong. Okay, mistake there. So we have something like AC DC AC converter. We have a grid side converter and rotor side converter. Rotor side converter will be controlling the active and reactive power of particularly the machine. Okay, and the grid side converter will be controlling the DC link power particularly and the reactive power being injected to the grid. So which is very, very important. Particularly what we are trying to do, we are, if you just see the previous comparison, it is only the grid frequency it is being connected. Okay, it is available. Not as any other frequency, I can change on the frequency and control. Now here, the frequency I am trying to take in my hands. Okay, and trying to control in respect to variable voltage, variable frequency. So VVF control. Okay, or I can go with say V by F control. So wherein I can maintain that ratio to be constant and control the speed particularly. And of course, please remember, along with that, pitch regulation system is also there. So next one is either I can go with gearbox without gearbox or permanent magnet synchronous generator. But here the problem with previous one is to just see AC DC AC converter is connected to the rotor. So that means only 30% of power is required. Okay. So here it is not like that. It is full scale converter is required, which is the it will increase the cost. And the biggest problem is with respect to the life of the permanent magnet being used. And it is magnetic feature and here that is not at all the case. Actually, the advantage is both the rotor side and stator side can control the power too. Okay, both from different routes, both different routes. And unlike the permanent magnet restrictions, it is not like that. So that is the advantage. Okay. So you have something like grid side converter control and rotor side converter control. So here I can, it is old one. Nowadays the technologies have changed, but I will show in the next slides. So grid side converter I can control simply by PWM or space vector PWM, and even rotor side converter I can control it with by PWM or space vector PWM, along with different control strategies and different controllers. Okay. So we have old kind of system they used to do. They say like these are the things they have been put on, but never any kind of turbine manufacturer has been they say this is the technology being used. Okay. Only thing is the person over there who is working, they will be trained or they have to know what is the technology being used. Okay. So we have something like load angle control technique and vector control technique. And grid side converter side, we can go with load angle control technique. But now it's obsolete. we are not using that. Okay. So load angle control, like this is how the circuit diagram goes. Okay, and I have power system people particularly on that the concept being taken from power systems only. Okay, so it is the equation being applied over there, and they will be using that on the parameters over there. Okay. So vector, particularly I can go with the dx and q-axis kind of. Here particularly torque I can control with the starter current. Okay. So these are the equations related to that. So this is what I was mentioning. This old, but here particularly what this is part of my research work at the time. So fuzzy logic, this is again old only, not too real. Fuzzy logic, it's not a new thing. Okay, but we can go with that kind of controller, particularly to be applied for the rotor side converters. So here, for the rotor side converter, this side I have applied the fuzzy logic controller. This side is normal PWM technique only. Okay, so the exploded view of the fuzzy logic controller being used and gate side converter control being used. Here, particularly, I have gone with hybrid technology, hybrid topology. ANN and PI both I have put down. Okay, so wherein so this will be having better performance compared to ANN or PI individually. Okay, this is rotor side converter and we have some people, maybe not in India still. We are going for vector control only, but the people from the other countries, they are going with that direct torque control. Again, old topology only, but old control strategy only. But here, particularly, rotor for the flux reference generation scheme was used. In particularly, what will happen is to the rotor side converter, if there is any fault, say voltage dip will be the next thing which will be occurring. Which will say voltage dip will be the next thing which will be occurring, which will be leading down to heavy current in the rotor side converter. So that is it may damage that AC/DC SC converter totally. So that will that should not happen. That we need to restrict. So we will put down a crowbar resistance immediately, shrinking down with crowbar resistance and protecting down the rotor side converter. Okay. So here, at that instant, grid side converter will be acting as STATCO. Okay, that is important, and it will try to give the inject the reactive power so that the voltage will be restored back and the system will be restored back to the normal, and not making the system or wind turbine to be stopped. It will be continuously generating the power. Okay. So if there is any fault, particularly on the system. So one more technique you can go with DPC, direct power control, same as direct power control. This is how the topology will be looking like. Total exploded view of DPC being also given. You can even go with predictive direct power control and predictive direct power control too. Sometimes this can be applied as a motor application. You can go with that also. So wherein we need to reduce down the ripple content in the system. All the particular flux ripple, we will try to reduce down that. So overall, that we have in importance like direct drive, which is power line synchronous generator, and W-fed. You just see the comparison. So it is aerodynamically efficient, simple and robust. Constant speed type, it is simple and robust. Aerodynamically efficient. W-fed, it is aerodynamically efficient. Technically efficient, it's constant speed type or fixed speed type. It is less mechanical stress. It is also less mechanical stress. It is standard. That is large converter. That is a disadvantage. And here W-fed, it is small converter. Gearbox included, no gearbox. That's the advantage for the direct drive. And standard generator. That is with the gearbox it will come. Okay, and any kind of system, this short circuit ratio is very important. Short circuit power level or short circuit ratio, and grid short circuit impedance angle is very important. So, if you take down, okay, generally this kind of systems are connected down to weak grid only. Okay, because it is voltage fluctuations will be happening. So it is because it would be in remote locations. So generally RSC below 20 is considered to be the weak grade. So where RSC is nothing but the ratio of the short circuit level to the rated apparent power. Okay. So generally that would be there, but we need to see that the control strategy being put on is very good, and it would be uh, what is it, compensate these kind of issues. Okay, make it standard operating conditions. Okay, this is how short circuit condition, subject ratio being calculated. Not necessary. This just I'm skipping off power quality. So either whatever we are injecting, without any disturbance, voltage or current, without any harmonics into that, it should be injected into the grid. Okay, it should be connected down to the point of common coupling, injected to the point of common coupling. In that way, our system should work. Okay, so these are the parameters where this is again called here, taken as voltage fluctuation and harmonic flicker and contribution to fault currents. If you just compare direct drive and WFID is bit good, okay, more good compared to constant speed. First point, the double is quickly disconnected. Downwards gate code says it should not disconnect. It is there with the fault rate to system. So okay, we have we just now what we considered with control strategies. All these things can be done. Active power control, frequency control, and voltage control too. Okay, so that overall the much amount of disturbance or any kind of deviation with voltage or current should not happen, and it should be injected to the grid. Okay, so this is what with nowadays the wind turbines are coming up, fault rate to particularly. Okay, and maybe the system may be restored to the not 100%, may not be 100%, it may be 93%, but nowadays like things are moving in a good manner, like technology like DTC or DPC, they are being embedded and they are trying to make the system to be normal working. Okay, and the regulations particularly they say particularly this renewable energy should not hamper particularly the overall power system. It should work according to the grid codes particularly, and if there is any application, like UI charges will be put on. So this is a mechanism for the regulations, particularly renewable energy certificate regulation. Okay, and Indian electricity grid code says like wind power plant. It's a must-run operation plant particularly, and control of both this reactive power drawing and injecting to the grid should be there. And reactive power drawing during wind power generator startup should be also considered. Particularly, it should be within the limits. Wind power or wind energy forecasting of scale of the wind generation should also be, uh, as per the whatever we are giving to the GenCo. Otherwise, your charges will be levied. So that is what it says. So that's what here is the last line. Your charges for variation within plus or minus 30%, it would be levied. So not much variation. If it is good, like whatever we are predicting, it is exactly matching, then no UI charges being levied. Okay. So that is what here given. And as I said, it is 15 minutes now. Forecasting now they are taking for its wind power generation. So overall summary, conclusions. Electricity, the electrical system topology of the wind turbines, what we have covered. Okay. Grid system and properties at the point of connection, that is also important, and we need to take care of that. Possible impacts of the wind turbine on the power system. Almost all different types, particularly forecasting and within minutes, like 15 minutes nowadays. That is also important. Reactive power conversion schemes employed, say DFIG, if you take, that itself, grid side converter itself will be acting as STATCOM. So that kind of schemes we need to see. And interconnection standards, particularly, we need to follow, say, some standard codes, particularly being given for interconnection between one system, like say hybrid or wind to grid or solar to grid. So I have taken references from CWIT, now NIWE, Global Wind Energy Council, Siemens Gamesa, Vestas, and Windstream Technologies. Thank you. Any doubts you can ask?
So, sir, for a valuable session, I request the participants, you can ask the queries about the presentation.
Sorry, I was a bit weak for the second half because time is also, almost 12:10. I've taken more time. Sorry for that.
Okay, sir, no problem, sir. No issues regarding this. So, once again, I request the participants, you can ask the queries. You can unmute your mic and you can ask the queries. So, meanwhile, sir, I will go through the queries which are typed in the chat box, sir.
Okay, sir.
So, sir, there is a query from one of the participants, sir. Sir, can you explain which wind turbine is suitable for Andhra Pradesh and why? Whether it is an horizontal or vertical axis wind turbine, sir? It is a very much.
Yeah, yes, sir. If you just see the Windstream Technologies, it is the best suitable for the small scale, so small wind turbine application. So my sincere advice, say either you go with installation at the top of your home or house particularly, or if you go with your college, any other combination will be always good. So because please remember, either I need to sacrifice night time, okay, either I need to sacrifice daytime for wind. Okay, so both that would be good always. So that's one simple solution. And if you go with that small type of wind turbines, it is vertical axis wind turbine in especially that if you just see 7 years type. Okay, and if you go normally don't want to go that kind of thing. If you want to go with what is the high power range, then it is horizontal axis wind turbine only. So, but better now latest one which is available, if you install that would be good. So otherwise again repowering that would be a big headache. So there is a thing, sir.
Sir, one more query from another participant, sir. So how can control maximum power extraction and grid synchronization for wind energy systems, sir? How can control synchronization for wind energy systems?
Okay, sir, few things are there here. One is I can regulate my power. Say if I go with the horizontal axis wind turbine, I can regulate my power with the pitch regulation too, and place my wind turbine in good wind speed with say yaw drive. Okay, so that is one aspect. Other aspect is now how much amount of power I am generating. So sorry, I can't able to draw. It would be like the sigmoidal kind of curve actually. So now I need to tap down the maximum power actually. So maximum power point over there. Okay, it would be varying depending on that situation. Either it may be solar or wind. It would be varying. Now what I will do is I will go with either quarter band observe method or hill climb search or incremental conductance kind of thing. So to apply that kind of algorithms to my system and tap down that maximum power point. Okay, so along with that, this kind of topologies like control strategies like DTC, I need to put down so that overall this can be done simultaneously and to my point of common coupling, I'm injecting proper amount, sinusoidal values of voltage and current. So that is what all this will come down like the mixture. But only the thing is, some may be concentrating only on MPPT. That is not correct. We need to concentrate all this. MATLAB will be, even if you take MATLAB or any other software like Typhoon Hill, you can go with all these things. But only the thing is, sometimes we'll concentrate on only one thing. That's the wrong thing what we'll do, sir.
The query, sir. So how to model wind turbine in MATLAB, sir? So this is the query asked from one of the participants.
Yeah, actually, my advice for that is like, mathematical equation modeling is always good. And if there is any new parameter, new kind of technology like say example, permanent magnet synchronous generator for my small wind turbine, that would be completely different kind of, uh, say down. Where somewhere like mathematical equations will be also changing. So that is always good to go with mathematical model, that kind of that wind turbine. But if you don't want to go, it is actually little complex only, because you have flux equations, torque equation, all these things. You need to see that each and everything how it is correlated, and the standard papers are there. You need to go come across with all these things and develop. Or otherwise, in MATLAB it is already available. Direct wind turbine, different types of topologies are also available. That's the thing, sir.
Sir, one more query, sir. How can we reduce flicker problem due to variable speed during power generation, sir? How to reduce the flicker problem due to variable speed during power generation?
Sir, here simply, actually, if you take, I've just shown the slide, W-feed induction generator, nowadays we are going for these two technologies only, W-feed induction generator and permanent magnet synchronous generator. The control strategy which we put on along with that it will itself will take. It is unimportant for us to take flicker, because the amount of rotor voltage or rotor current which is required. So at that instant, if that that thing is also there, but it will take care how much amount of rotor voltage or how much amount of rotor current has to be put down or controlled. That delta X, say, that change that would be taken care by the control strategy itself. So it will be automatically taking that clear the flicker. So no issues, no need to worry at all. But if you come down to smaller kind of systems, either we need to put on this kind of topology in that also, or otherwise we need to put on some kind of filters kind of thing, not to allow any kind of flicker. That's the thing, sir. Hello?
Sir. Hello? Sir.
Yes, sir.
Okay. So one more query, sir. Any particular website from where wind data for a particular site can be obtained from last 3 to 5 years, sir?
The problem is, like I said, like NASA is one side. The problem is they are giving for 50-meter hub height only, not the other hub height. The thing. Okay. Thing is Kaggle, Kaggle. Okay, Kaggle. Just type down in Google, you will get that. But the problem is like the wind data or solar data is not available for India. It is available for even 30 years, particularly for European countries only, not for India. That's the problem. Either you need to go NIWT, you need to ask for them to request them particularly and see their sites. Particularly NASA will give only for this 50-meter hub height.
So one more query, sir.
And see the research purpose related to this. The combination is new things, sir. Thermal and wind. Solar PV and wind is there, sir.
Sir, one more query, sir. Any work going on power control technique of DFIG using machine learning, sir?
Yes, going still, but people, the big problem is what I have faced is they are not giving the data. Okay, data. Say example, if you go to Tadipatri, visited many times, the data particularly they are not giving. Even the people from Transco people, they will go for reading and take the reading from there. They know only the reading part, but inside data, complete data. So say this time what would be the wind, how much power being generated, that they are tapping down directly remotely and through their station at say Hyderabad or Pune. And if we are asking also, the data is not giving even. Once the data is available, then we can go for with even researchers or people like us, they can go with machine learning. But the people from the companies like Siemens Gamesa, they are doing, sir. They are already doing the things. Say JNTUH, we have one project for Madam, but they are not doing any machine learning. I don't know about IITs and NITs. But people are doing, sir, already. They are doing machine learning application to this.
That's all the queries, sir.
Yeah. Yes, sir.
Thank you, sir, for your response for the queries. And now I request the convener of this STTP, Dr. K. Sudhir, to give the vote of thanks. Sudhir, sir.
Thank you, Vinod, sir. First of all, I would like to thank participants and today's resource person, Venumala sir. It's our honor to have you as a resource person for our STTP. This might be the first, and it may go along in future also. We request you for other programs, whichever we can, sir, because this session really impressed our participants. And personally, some of the participants have given very good feedback, sir. Thank you so much for your valuable time spending with us and delivering. Yeah, participants at afternoon. So be there on time by 2 o'clock.
So able to see the typing in the chat box.
Really contact us. Sir, is there in the chat box, sir? So the mail ID.
This is my contact number, sir, and that's my email ID.
Yes, sir. We got the idea, sir.
Okay.
Thank you, sir.
Thank you, sir. Thank you very much.
Thank you very much.
Thank you, Venu, sir.
Thank you, sir. Sir, can I leave the session?
Yes, sir. Yes, of course, sir.
Yes, sir.